Okay, this is lesson 10.3. We're in chapter 10, third section, operations with radical expressions. So we're going to add and subtract and multiply radical expressions today. So if you think back a few chapters of polynomials, and we had 5x plus 7x minus 6x, we'd say, oh, that's 12x minus 6x, and you're left with 6x. The same is going to go for radicals. So we have 5 root 2 plus 7 root 2 minus 6 root 2. It's the same thing. 5 plus 7, 12 root 2 minus 6 root 2. And 12 minus 6 is 6 root 2. They have to have the same what's called radicand. The radicand is what's ever underneath the square root symbol. So they all have the same radicand of 2. So you just combine like terms. Let's try it again over here. A 10x and a 4x go together to be 14x. A 5y and a negative 6y become a negative 1y. So same thing here. A 10 and a 4 here become a 14 root 7. And since the radicands are the same here, a 5 root 11 minus a 6 root 11 is a negative 1 root 11. Same concept. So what if they're not all the same? Well, maybe they can be simplified. So if I have a 2 root 18, I see that this is 9 and 2, and then I see this is 3 and 3. So I'm going to rewrite this as 2 root 332. I'm just going to leave it there for a second. I see 32 as 4 times 8, which is 2, 2, and 2, 2, 2. So I'm going to rewrite this as 2 root 2 times 2 times 2 times 2 times 2. And 72 I see as 9 and an 8, which is 3 and a 3 and 2, 2, 2. 2, 2, 2, and 3, 3. So I'm going to expand each one so that I can simplify it. Well, I have a 3 here. If I take out a 3 and put it in front, that's going to be 2 times 3 root 2. Pause. I'm going to leave it there like that for right now. I have a 2. I'm going to bring it out. I have a 2. I'm going to bring it out. Don't forget about this 2. It's going to be 2 times 2 times 2 root 2. Here I have a pair and I have another pair. When you bring them out, it's going to be 2 times 3 root 2. That was a lot. So you have to look here and say, can the radicands be simplified? Yes, they can. I rewrite them in prime factorization so that it's easier for me to simplify. Now I start cleaning it up. This is 6 root 2. This is 8 root 2. And this is 6 root 2. They all have the same radicand. So this is going to become 12 root 2. All right. Pause the video and you try this one on your own. All right. We break down the 54 to 9 times 6. The 3's come out, so it's 4 times 3. And then the 2 and the 3 go back together to be a 6. Here, 24 is 4 times 6. Bring out the 2. So it's now 12 root 6 plus 4 root 6, which is 16. Here, 2 times 12. Well, 2 times 12 is 2 times 6, and 6 is 2 times 3. 54 is 9, 3, 3, times 6, 3, 2, plus square root of 96. If you have to go off to the side and do it, please do it. I'm doing this in my head because I've done this so many times. So 96 is 2 and 48. 48 is 2 and 24. 24 is 2 and 12, and 12 is 2 and 6. I'm just going to leave it as 6 because I know that doesn't really break down or do anything. So I have a 2 times a 2 times a 2 times a 2 times a 2, 6. Okay. Have a pair, bring it out. Have a pair. I have 2 pairs, so it's a 2 times 2 out there, which is going to be a 4 root 6. So I'm going to have 2 minus 3, which is negative 1. And then I have a negative 1 and a 4, which is a 3. That's it. All right. Second sheet. We have a 3 root 2 and a 2 root 6. The multiplication is actually easier. So whole numbers go with whole numbers, 6. Radicands go with radicands, 12. Easy, right? Can this be simplified more, though? 2 times 6, we could have just left it like this, which is 2 times 3. Oh, take the 2 out. 2 times 6 root 3, your answer is 12 root 3. Here, we're distributing to each term. 3 times 2 is 6. 5 times 5 is 25. Plus 3 times 5 is 15. 5 times 3 is 15. All right, well, we know the square root of 25 turns into a 5. So put parentheses because they're beside each other. That implies multiplication. 15 just breaks down to 5 and 3, so that really doesn't do much. So this is going to be 30 plus 15 root 15. You can't combine them anymore. They're not alike. Okay, I want you to try the next one. So please pause the video and try it on your own. Five times 3 is 15. 6. 5 times a 1 is a 5. 3 times 3 is square root of 9. We know 6 can't break down anymore. But we know 9 is 3. So that 9 turns into a 3 because it's the square root of 9. So 15 root 6 minus 15. You could leave it like that. We tend to write the number in the beginning. Either way, I'll accept. Okay, last one. It says find the area of the rectangle. Well, area of a rectangle is length times width. So the area is equal to the length, which is root 5 plus 4 root 3, times the width, which is 5 root 2 minus root 3. So the area is FOILed. Technically, there's a 1 here. So 1 times 5 is 5. Root 5 root 2 is root 10. 1 times a negative 1 is negative 1 root 15, because 5 times 3 is 15. So first outer inner 20 root 6. 4 times 5 is 20. 3 times 2 is 6. And last, 4 times negative 1 is negative 4. 3 times 3 is square root of 9. So let's go through. 10 just breaks up to 2 and 5, so there's nothing we can do about that. 15, we said, is 3 and 5, so that doesn't break down anymore. 6 is 2 and 3, that doesn't break down anymore. 9 breaks down to a 3. So this becomes negative 12, 5 root 10, root 15, 20 root 6. It doesn't matter the order you put it in, for me anyway. The book really doesn't say any preference, but they're all different, so they can't combine. So this is the area. And what do we know about area? It's units. We don't know what the units were. If it was centimeters, inches, units squared. Okay, that's it. I know it's a little intense, but work on your Delta math. And if you have any questions, feel free to email us or Zoom with us.